uh, video class. We are back with our workshop paper for section B listing part 1. As we already say, chemistry was made the simplest. And if you have been really following Muto online classes, I know you found this paper so cheap because we had covered all the concepts that were said. And those who used to attend our classes, surely everything that was said in Wakissha was part of what we've actually just previously taught. We are now back with our section B, part 1. For part 1, I'm only going to respond to one because I just taught one that of iron. I just taught that extraction of iron previously. Actually, not even a week. I'm going to take you through item 3. Remember, these section B part 1 items are items of industrial processes which we know the format of expected response. A learner is expected to state the raw materials. A learner is expected to describe the process of production. A learner is expected to give and explain well the social benefits of the process of production, side effects and mitigations of the process of production. Members, item 3 goes, sodium hydroxide is a useful chemical compound that is used in different chemical processes, like in the manufacture of soap, which is a major cleaning agent. Due to its benefits, the ministry wants to start producing sodium hydroxide locally in order to cut the costs incurred during transportation. However, the environmentalists and some local leaders are worried of the impact of the plant, and the government is planning sensitizing of the community about sodium hydroxide production. And the task is, as a chemistry student, write an article to the government, to the government newspaper to sensitize people on the plant being established. So they want us to write about shortly the process of manufacturing of sodium hydroxide. So you have to state it clearly, and this is a process of manufacturing sodium hydroxide. Remember, the raw materials for this process of production are simply that is concentrated sodium chloride solution, which is usually brine, or usually known as brine. You can alternatively call it concentrated sodium chloride solution. We need graphite. We need mercury as well. This is a simple process of production, and this is taught under electrolysis, because we have electrolysis. Most of it is electrolysis. I've actually just taught this topic. Members, the process of production occurs in what we call an electrolytic cell that is made up of graphite as the anode and mercury as the cathode. Remember, as you're explaining, as you're stating the process of production, you have to state the vessel. And we said a vessel is a container where the raw materials are converted to the desired product. So what they do, the sodium hydroxide is always manufactured by the process of electrolysis of brine in an electrolytic cell. In an electrolytic cell, and this electrolytic cell is made up of graphite anode, and a mercury, actually a flowing mercury cathode. The cathode is made up of flowing mercury. So remember, we looked at the theory of electrolysis. When brine, it is so concentrated sodium chloride. When this electrolyte is electrolyzed, we know that it will decompose. And in the decomposing, since it is a solution, it will give us sodium ions and hydrogen ions as the positively charged ions. The sodium from the hydrolysis of sodium chloride and the hydrogen from the hydrolysis of water that is making it a solution. And then the anions that we shall form shall have the chloride ions from the hydrolysis of the sodium chloride, and then the hydroxide ions from the hydrolysis of water, which is making this brine a solution. So this results into decomposition of the brine, decomposition or ionization of the brine to form sodium and hydrogen ions, and chloride and hydroxide anions. Remember, as in the previous videos, we said that the cations are the positively charged ions, and the anions are the negatively charged ions. So the ions we shall form from the ionization of this brine, the electrolyte, are these ones, for those reasons. For now, they're asking for the manufacture of sodium hydroxide. That means from this electrolyte, from this raw material, what we need is sodium from it. So I'm now not going to go into the details of the chloride and the hydroxide ions. I will need the anions if they are asking for the manufacture of chlorine gas. Because to form chlorine gas, we shall need to discharge the chloride ions, as we shall see. But for now, they're asking for production of sodium hydroxide, which will come from the sodium in the raw material. So this means we are now going to deal with the cations. And remember, we said that the positively charged ion is formed as a result of decomposition of the electrolyte, always migrate to the cathode. And we said the cathode is a flowing naturally cathode. So I'm now going to talk about only these ones, the sodium and the hydrogen ions. So here, the sodium and the hydrogen ions flow to the cathode. Remember we said that once the ions are at the electrodes, they are discharged. And we said discharging is converting the ions to respective elements. Removal of charge. But we also looked at the properties that determine the choice of discharge of which ion. The choice of discharge depends on a number of properties, factors, where we looked at nature of the electrodes. Remember, we looked at the concentration of the ions, and we said that the ones that are more concentrated are discharged in preference of the other ones that are less concentrated in solution. And we also looked at another factor, which was the position of the element or radical in the electrochemical series or the reactivity series. So here the factor they are talking of, since this is brain that was decomposed and that was used as the electrolyte, it means that we are now dealing with the concentration of ions. And the ions now that are more concentrated are the ones of sodium. So they will flow or they will migrate to the what? To the cathode, where the sodium ions are discharged in preference to the hydrogen ions due to their high concentration. Remember, this is a sodium chloride solution, meaning that since it is a concentrated sodium chloride solution, it has more of the sodium and chloride ions in it than the water ions, than the hydrogen and hydroxide ions. Since it is concentrated, and remember that the choice of discharge or the preference of discharge is always the ones that are more concentrated if the factor is concentration. So the ones that are more concentrated are discharged in preference of the other. And we said discharge is removal of charge forming respective element. So it is discharged due to its to form sodium metal. So this is what happens. What were sodium ions at the cathode will be discharged to form sodium metals a sodium metal, and this is, members, it will only happen if this one gains electrons. If the sodium ion gains electrons, meaning that this is reduction. So the sodium will be reduced to sodium, the sodium ions will be reduced to sodium metal. Members, this formed sodium will now react with the flowing cathode, the material in the cathode. I mean, the material forming up the cathode, forming what we call sodium amalgam. Which sodium amalgam will then dissolve in the water. Which water? We are talking of the water that was present in the electrolyte. And once dissolved in the water, what was the sodium amalgam of this formula? Once dissolved in the water, it will form the required sodium hydroxide, but in a solution state. And then we shall have the material back into the cell and hydrogen as the products. This formed sodium hydroxide will then be concentrated or evaporated to remove that water from it, to convert it to solid state. Remember, it is easier to store solid substances than liquids. So the purification, to remove the water in the sodium hydroxide, that is a purification stage. We shall purify it by evaporation. The evaporation will remove the water from the sodium hydroxide formed, forming dry pellets. Dry pellets of sodium hydroxide, which are packed and they will always be ready for use. So I've not talked about the reaction at the anode because the target was sodium hydroxide. So I'll talk about how I can obtain sodium from my raw material. It was the sodium that would help me to get the sodium hydroxide, not the chloride ions. So if the question was about chlorine, I could talk about what happens when the anions flow to the anode. And I would not talk about all of this of sodium hydroxide. Members, don't forget to talk about at least one social benefit. You talk about the social benefit, you state it, you explain the social benefit well, you give the impact of the social benefit. I've always explained this. I don't need to explain it again. And then a side effect, at least one well explained and given a respective impact and its mitigation. But of the process of production, not of the product. Members, chemistry was actually made the simplest. Imagine how many minutes did you need to do item 1, item 2? You only need to attempt only one item from section B, part 1, one from section B, part 2. It was actually made the simplest subject among all. Members, you need to make summaries of these industrial processes. You prepare a number of them, a good number of them. There are over 22 industrial processes that can be said. Can you please mention in the comment section how many you know? Because I know you have very many in your books. How many do you know? Members, item 4 was about the extraction of iron, which I've just taught recently. If you didn't attend that class, please look for a video about electrolysis. There are videos about the topic of electrolysis. We said you can forward, you can pause, you can rewind and see what you missed. So you can look for this topic of electrolysis, forward until when you get where we talked about the applications of these processes, of this process electrolysis. Actually, it was oxidation reduction reactions. The videos are there, the redox reactions. The applications, we talked about extraction of these metals. The summary is there about the extraction of iron. I beg not to repeat it. Not to go into details, Nana law has always been part of us. Kidega Daniel is part of us. And he's saying that I pray that God rewards you for the work well done. Amen. We appreciate Tony Godfrey is always with us. Salah Banks is with us. You're most welcome, please. I really appreciate the good job you have done in us, teacher. You're most welcome. We also appreciate you to always give us the men are sleeping. We are grateful also, always have you. I beg we call it a day. This is Teacher Alan. More videos coming. Thank you.